2a, we have y equals cos of 6x. What kind of transformation is that 6? It's going to be horizontal compression by 1/6, right? So if we were normally drawing our cos graph, well, a horizontal compression is just going to affect the x values. So what we're going to do when graphing this one is it doesn't affect our y values. Does it make sense that this one has an amplitude of 1? And it's going to go up to 1 and down to -1. Now the period is normally 2 pi. What will the period be now that you've compressed it by 1/6? It's going to be 2 pi over 6, which is pi over 3. So if you had 2 pi over 6 or pi over 3, and then you broke it into 4 equal sections, what would the middle section be? What's half of 2 pi over 6? 1 pi over 6. What's half of pi over 6? Pi over 12. So when you're figuring these out, and we'll have all sorts of different numbers to figure them out, this is the method that we'll use. We'll start with what one full period is. In this case, it's 2 pi over 6, or you could write pi over 3. Figuring out half of that is fairly easy. And it might even be easier had we written pi over 3, because multiplying pi over 3 by a half would just be multiplying that denominator by 2. And then multiplying that by half gives you pi over 12. And then I always count. This is 1 pi over 12. This would be 2 pi over 12s. This will be 3 pi over 12s, which you could reduce to pi over 4. But it's going to be easier to figure pi over 4 out if you count pi over 12s than if you just try to figure it out by looking at it. So what I did, as I said, this is 1 pi over 12 here, 2 pi over 12s, 3 pi over 12s, 4 pi over 12s. I'm just counting by that smallest amount. And then I reduced it afterwards. So now that we've done that, it's a cos graph. Where does cos normally start? At the top, at the maximum. So you go from maximum to middle line, to minimum, to middle line, back to maximum. And this is the graph compressed horizontally by 1/6. Now, again, it didn't ask us to graph it, but for each of these we're going to graph them to get used to that. And then we can write what the period is, which is pi over 3. If you had left your period as 2 pi over 6, you would not lose a mark for not simplifying. Okay? And that 2 pi over 6 is really easy to see because you can say, my period normally was 2 pi, but when I compressed it by a 1/6, I'd have to multiply everything by a 6, so now my period would become 2 pi over 6. Part B, y equals tan of 2/3 x. So, what kind of, do we have a stretch or compression? Stretch. We would multiply all of our x values by 3 over 2. So if we think about our normal tan graph, right? In our normal tan graph, we had asymptotes at pi over 2, negative pi over 2, 3 pi over 2. They're going to get changed. So instead of having this one at pi over 2, where is it going to be at? Well, if we're multiplying our x values by 3 over 2, by the reciprocal, can you see that you'll get 3 pi over 4 and negative 3 pi over 4. And this one was at 3 pi over 2. If you multiply that by 3 over 2, you'll get 9 pi over 4. And your graph of tan, you'll find that it's quite easy to do it using your asymptotes, well, if I multiply 0 by anything, that'll stay 0, so your shape stays the shape. Stays the same. Your shape stays the same in that middle section. You could figure out this point. That point was at pi before, but if we multiplied it by 3 over 2, then it's going to be at 3 pi over 2. And of course, it would continue with this on both sides forever. Now that we've drawn it, what is the period here? Well, how far is it to go from this asymptote to that asymptote? Three pi over 2, or if you added these two parts together and had 6 pi over 4, that would be fine. Because 3 pi over 4 plus 3 pi over 4 would make 6 pi over 4 when adding those. Now, does that make sense? What was the period originally for tan? Was pi. And we've multiplied by 3 over 2 because we did a stretch. So now our period is 3 over 2. And part C. What's going to happen here? A bigger thingy? Yes. The stretch, horizontal stretch by 7. Okay. So if our period was 2 pi, again, it's still going to go from 1 to -1 because our y values aren't changing. But instead of marking 2 pi along here, if we stretch it by 7, it's going to be it's going to be 14 pi. I missed that. What's half of 14 pi? 7 pi. What's half of 7 pi? 7 pi over 2, or 3.5 pi. But if this is 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s, how would you write 3 7 pi over 2s? Does that make sense for 3 7 pi over 2s? 21 pi over 2. And it's a sine graph. Where does sine start? On the middle going up. Now at the bottom of the page, they have a couple of formulas for you in that little yellow box. There. For sine and cosine, they have a formula that says, so let's write this off to the side. For sine and cosine, your period is always 2 pi over your b value, which makes sense because if your b value is a number like 2, well, you have to multiply by the reciprocal for your horizontal stretch or compression. And so all this b on the bottom is doing that reciprocal. It's taking the b value and by dividing, it's like multiplying by 1 over b. Okay? If you wanted to rearrange this formula, and sometimes you'll be given the graph and you need to find the equation, when you want to write whatever that b value is, it's going to be 2 pi over the period. Now that's for sine and cosine. for tangent, your b value, or sorry, your period, instead of 2 pi over your b value, since the period is since the period of tan is pi to begin with, it's going to be pi over your b value. And similarly, you could rearrange that to get b by itself and get pi over the period. Yes? The b value is whatever is inside. Eventually, we're going to have a bunch of letters. A, sine, b, x minus c plus d. Alphabetical order for the letters. So A stands for all of your vertical stretches and compressions, which also corresponds to A for amplitude. Okay? B is going to be all of your horizontal stretches and compressions, which corresponds nicely for B for period. Okay? And then we've got C will be our horizontal shifts and D will be our vertical shifts. Yeah, good. Some of you got that. A for amplitude, B for period. Okay, so going back to our question now for example 2, and we'll take some time to work on these. You can now also do 3, C, and D.